All right, here we go.
True to integrals. Oh no, that's not good.
No, it'll be fine. It's good. It's very fun.
It's
very fun. Not confusing at all.
Okay, so we went through most all of physics past 7 weeks. We're now going to go back through physics with the understanding that calculus is a thing. So here's some, if you are in BC calculus, let me show of hands. How many people have already taken calculus? Okay, this conversation is not directed at you. Okay? So these are things that you have not yet been introduced to, unless they've changed the curriculum. So if you have a function e to the x, the derivative of that is e to the x.
Yes.
Okay, it's a nice one. Okay, if you have a natural, your function is natural log of x, the derivative of that is 1 over x. Those are just memorized stuff. Okay, so sorry, I should have given you an example of this. So you're going to use chain rule. So taking the derivative of this is going to be equal to e 2x squared plus 3x, and then you're going to do the inside, so 4x plus 3. And if you have taken calculus, if I do mess up, please let me know. Like, my calculus is a little rusty. You guys are like in it. All right, so here, this would be the derivative of that function would be 1 over 3x plus 1 times 3. From is the chain rule? Is that am I calling that right? Okay. Good with that. So do the derivative of the little thing and then the inside. Good. Okay. So here is a really important thing that you may or may not have picked up in calculus. And this is true just for any type of equation, but with a derivative, you're finding the instantaneous slope at a point. Hopefully that's already in there. You're dividing the units of the two axes. Okay. So when you do dy over dx, these have units. Whatever on the y and the x-axis, those are like you're dividing those units. Okay? So like dx dt. Well, I'm kind of getting ahead of myself. Okay. So you have position as a function of time. You got something. If you take the derivative of that, that is meters over seconds. Okay? Crazy, yeah? I know. Okay, so that gives you the velocity of the function of time. If you take the derivative, we can label that as x prime t. There's also textbooks that give a dot. That's a college thing. I haven't seen it in high school, but college, that's a thing. Okay. So the second derivative, so dv dt, that's going to be meters per second over seconds. Gives you acceleration as a function of time. And so you get x double prime, or you get x double dot.
Yeah.
Okay?
Could you also put it be dot or x double dot?
You could. I've never seen it, but I don't think that's breaking any rules. Usually they bring it down to the base. Good question. Okay. Everybody go with that?
Yep.
Yep. If you take the third derivative, this is the rate at which acceleration is changing. That's a jerk. And then the rate at which jerk is changing is snap. And then the next one is crackle. And the last one is pop.
So many got
It's legit.
What's beyond
Okay.
pop?
I don't think
You
anybody
really
cares.
need pop? It's like the seventh derivative.
Right. That's
And when polynomials exist.
Okay.
you know,
Good. So this is also, this has the same thing for rotational. Okay. I mean, yeah, I don't want to waste your time, but you get that with rotational stuff. And yeah, so all that's still a thing. Okay. Yep. Yep. Okay. All right. So Newton's second law, net force is equal to mass times acceleration. From a derivative point of view, we would say we can do mass times change in velocity over change in time. I'm doing this algebraically, so you could do, so anytime the delta, we're going to change that to a very small, infinitesimal small change of delta, which is or the differential.
Is that what the name means? Oh.
Okay. Okay, so delta differential is just the limit as our delta approaches zero. Okay. So this we can change to change of momentum. So really, the derivative of momentum is equal to the net force. Okay? And that's how Newton actually wrote his second law of motion, which is more powerful than this because this assumes mass doesn't change. Some foreshadowing for the end of the semester.
I was worried about this.
How
Okay.
does one change the unit random
Just add more.
Just have mass.
You just pick it up as you go along.
Okay? You good?
Keep it vacuum cleaner, yeah.
And so you have the same thing. You have the same thing rotationally. Is the net torque is equal to the rate at which angular momentum is changing. Okay. So if you have your equation sheets that I let you keep yesterday, you might be able to follow some calculus with this.
Follow the trail.
All right. Okay. Good?
Oh, the change in momentum is equal to the integral of torque.
Okay, so power. This is the rate at which work is being done. So work is a process. So you can also have this. So this is instantaneous power. which is also equal to, I'm not sure why that's not on here. This is worth memorizing. Force times velocity. I don't know why they don't have that on there. It used to be on here. Strange. Yeah, memorize that. That's wild. So that also is instantaneous power. Okay, the rate at which work is done. Harmonic motion. You get position as a function of time. This is amplitude times the cosine of omega t plus some initial phase angle. You got it. This is initial phase angle. So this is you have a cosine graph. If the x-axis was here, sorry, the y-axis was there, your phase angle, I forget how this works. You shifted that this way. I think you're adding, you'd have a positive phase angle of like pi over 4 or something like that. And if it was like this way, please correct me if I'm wrong on that one. It's been a long time. If I go that, if I shift, if this goes this way, or the graph goes that way, it's a negative phase. It just tells you your initial, where you're starting from.
Yeah,
Okay.
can you re-explain that? I was writing.
Which part?
Just like what the initial phase angle is.
It's what angle it starts at. So this would have an initial phase angle of 0 that we start at cosine. If this is where the y-axis is.
Oh, so it's just like the phase shift.
Yeah.
Okay.
Good with that?
Yep.
Yep.
Is that velocity?
Good question. So in circular motion, rotational motion, this is angular velocity. In simple harmonic motion, this is rotational motion. In simple harmonic motion, this is called angular frequency. So it's how quickly you're going through 2 pi. Does that make sense? So it's in a circle, how quickly you're doing this, rotational velocity or speed. In simple harmonic motion, it's how quickly you are repeating the pattern. Does that make sense?
Is it still a W or is it like an omega like
It's
this?
omega. Yeah, both are omegas. Good with that? Okay. And so what this is doing is, where this comes from is this comes from omega is equal to the rate at which theta is changing, final minus initial over final clock reading minus initial clock reading. most always, we're starting our initial at 0 and time at 0. So you just get this. So you get this expression, omega is equal to theta over t, and then you bring this over. So that's why we can take the cosine of this, because this is really in radians. Seeing how that's working? Okay. So, and then this is your amplitude. How are we doing with that? Okay. Have you guys done derivatives with trig functions
Yes.
Yeah.
in BC calculus?
Yes.
Okay. So, if I take, everybody good with this? Okay. If I take the derivative of this, I get velocity. So, chain rule again. So I get the derivative of cosine is a negative sine, yes?
Yep.
And then I need to take the derivative of the inside, I get omega. Okay? So really, how you'll see this written a lot of times is A omega sine omega t plus. Okay? And if you take the second derivative, oh, I already used green, just kidding. I think colors help. Do colors help you? That's just me assuming, trying to make connections here. So, second derivative is acceleration, no time. So we're gonna take the derivative of this. So the derivative of negative sine is a negative cosine. So we're going to negative A omega cosine omega t plus phi. Take the derivative of the inside, I get another omega. So you'll see it written like this: A omega squared sine omega t plus. Josh.
How do we determine that since cosine originally for like x and t?
Beautiful question. Often, in a physical sense, we start, you don't have to do it this way, but oftentimes, time starts at maximum displacement. So like a pendulum, it starts out here and swings, okay? Or a spring, it's stretched and we let it go, time this. It doesn't have to do that. They can drop you in the middle of like, hey, let's start the time right when the thing's running through the equilibrium point. And so you can switch between sine and cosine, and sometimes I've seen AP questions where they're like, hey, mess with you. Here's this. You guys know math. Go for it. So it's not a, so you won't see these equations on here because it's not like a defined as. Okay. Anthony, or Antonio, sorry. What?
So we should like memorize them and like find out how.
Yep.
they work.
I would. Okay, so here is, I feel like I'm going a little too deep here. I think we're good. We're just gonna call that good for right now.
Just gonna make us fun jerk.
Okay, good with that? Okay. Yeah, no, I'll just leave it. We have it all up here. So like, in in 10 weeks, I'll say, remember when we were first learning about derivatives and we did this? And you're like, oh, yeah. Okay, so acceleration here, this is a hallmark of simple harmonic motion. Acceleration. See this? See this?
That should be
Oh,
a
come
cosine.
on, kids.
I don't think I caught that, but I did.
All right, that's cosine there, sorry. Okay. Did everybody see some similarities here?
X.
Yes, I get it now. Solve for omega.
All right, you seeing that? That's a hallmark of simple harmonic motion. Okay. And a lot of times when they say your maximum acceleration, that's going to be equal to negative omega squared times a. Because your maximum displacement is at amplitude. That's worth memorizing. That comes up a lot. But check this out. Tying it into simple harmonic motion, I'm out of colors. This blue does not correspond to this blue. Centripetal acceleration is equal to speed squared of the radius is also equal to speed, or rotational speed squared times the radius. See some similarities there? So if you're like, what is that? Like it's actually on your equation sheet, it's just hidden in centripetal acceleration.
Since we're just doing maximum acceleration, it's just the negative ladder that's not the
So that just means that as you displace it, let's say it's a spring in equilibrium right here, as you displace it this way, you have a positive displacement. The force is pulling back this way, so you have a negative force and a negative acceleration. What that's.
And that in the spring, the acceleration at max is it fully extended at that point?
Correct. Yep, because the force is maximum. Good? Okay. So, good? Yes?
Yes.
Good. Woo! Loving the application, yes?
Yeah.
Yes.
Personally, I think this is like a huge, I'm not gonna say a crutch, but it's a huge, if I get stuck in calculus, I can like refer back to physics. If I get stuck in physics, I can refer back to calculus. And like, sometimes they help each other. Does that make sense?
So if we have the acceleration of max, if we multiply that by the mass of the whatever object is being displaced, is that equal to max force?
All right,
Faster.
here we go.
It's thinner over there on that left side.
What is this one on the left side?
This is just.
Calculus, right?
They know derivatives. They're gonna learn integrals tomorrow.
Some of you guys have had calc, right?
Yes. Tell your neighbor.
Because velocity slope is changing. Your acceleration is changing.
That's the velocity slope is
It's
changing.
it's a
It's a local maximum.
Yeah.
So the derivative is at zero at that point, 'cause that's a critical point.
The second derivative of that is negative.
Talking now.
This is actually what we're doing right now.
It's a critical point.
Yes, I
It's
can.
a-
Just think about that, because it's like it's gravity. It's gonna
Yeah,
happen.
well, okay.
I also did it. Most of them are wrong.
I was gonna say, just don't even think about derivatives, just be like, it's gravity, it's down.
What's it called? It's concave down.
Concave-
No,
yeah,
it's
this is
concave
concave down.
down.
Yeah.
Which means
Yay.
it has to be.
Correct answer is
Gravity.
Correct answer is B. Yes, it is.
It's a possible point.
Okay, so,
It is a point of deflection.
so, critical points, is that a thing? I mean,
Oh.
okay, sorry.
No.
Have you learned it yet?
Yes.
Critical points, like
Yes.
first derivative test?
Yes.
Yes,
We just doing it.
we just did the second derivative test yesterday.
Oh, perfect. So you know this?
Yeah.
Yes, actually.
Yes? Did I give you this? I mean, this was in my high school textbook, and it's like fused to my brain. I'm like,
Yeah, can't.
Can you
That's
review
not
for
what-
like,
This is not point of inflection.
It's like-
I've never seen second derivative.
point of inflection breaks this rule. Point of inflection, yeah. You just,
Take the second derivative equal to 0 if possible.
Function is increasing, but the first derivative is negative, that means it's conjugate down.
no, concave. Wait, yeah.
Concave
Functions
down.
increase, yeah.
There's like a table for it.
Or you could just do the second test.
okay. So,
Well, not everything has a
does
second.
everybody see how second derivative, this is a frowning face? So this means that the acceleration is negative. You could also do a story. You're slowing down in the positive direction and then speeding up in the negative direction.
Comfortable.
Everybody good with F. Good with F?
We're so bad. We're so bad. We're so bad. It's an all-time low now.
I've been thinking about that one multiple choice question. It lives in my mind rent free.
Tell your neighbor.
One is negative.
Tell them how you got there.
Three is positive. Is that the, okay, I didn't look at the answer, I just knew what it had to be. Yeah, it's
Okay, that's a point of inflection.
one inflection.
That's not the
I
right.
think this is a struggle. It's been so long since we've done like critical numbers. It's so long.
Critical numbers and multivariate.
We talked about them like twice. It was just like random, like you remember.
I do remember
We
that.
like discussed
What do you
that.
say?
That's how I felt
Have
about
fun.
someone asking me to go back and like remember how to do things.
Correct answer is, I like B. Okay, frowny face, smiley face, this is the transition. Point of inflection.
It's the flat face. Sad face.
Thumbs up when you got some. Have a conversation.
His velocity is to start negative.
Yeah.
Wow.
Oh, you're merged from. How'd it go?
I wonder where he was. It's so cool. I have a pass if you want to see it.
We're learning calculus.
Yeah.
Great. We're applying calculus. Yeah, they had to be like a.
Okay, what do you say?
C.
Correct answer is C. Here's how I would go through this problem. I first look at my critical points, and I boom, boom, boom. That corresponds with 0, 0, 0. That's my first anchor. Okay? And then I go, okay, that's a negative slope, so negative value. Positive slope, positive value. Negative slope, negative value. Positive slope, positive value. Okay with that?
Yep.
Okay, next. So same original graph, but now I want acceleration. Tell your neighbor what you think. Tell them how you got to that conclusion.
It's not possible, they are points of inflection.
It's concave up at the beginning, so your acceleration is at positive, it shouldn't be.
Also, if you just look at the graph, it's
No, it's
like
going down.
conflict is negative effective in
Velocity is decreasing. Oh, yeah, velocity is decreasing.
No, velocity is increasing, actually, that's a lie. Yeah.
Correct answer is
B.
I don't like concavity, it scares me.
smiley face,
Frowny face.
frowny face, smiley face. Okay? Transition between frowny and smiley, that's your 0 points. Good? Okay? So that is a 100% math trick. I didn't do any didn't do any physics there. That was 100% just like, look at the graphs. Okay?
Oh, yeah. Maybe let's do this.
One slide.
Oh, come on.
Wait a minute, hang on.
Wait.
Thank you, David.
I was gonna ask him
Everyone panics for all the crazy seconds.
Tell your neighbor. Everybody good with B?
Yes.
You stick in 0 for T, and you get -6. Yeah.
Notice that it has a T. No, it's about to take the derivative of it.
Yeah.
All the way down to acceleration.
Okay, next question. Same scenario, same equation.
Now I take the derivative.
In my wallet.
Wait, that's just good. Oh.
Let's see. Plug in 0.
Neighbor?
8.
Yeah.
You find away. 8.
Answer number 5.
Is everybody good with 8 meters a second?
Yes.
Take the derivative. This becomes 8 nothing times nothing. So that's your initial velocity. Guess what next?
I've already got the calculator.
I need this one. Oh, wait. Okay, sorry.
What unmistakable.
Tell your neighbor. Tell them how you got there.
Z.
You take the second derivative
Yeah,
and
second
ignore
derivative.
all of the stuff that doesn't have t squared.
Exactly. I love ignoring stuff. That's a good part of calculus.
Yeah, anything that doesn't have exactly two squares.
We're good.
I just hate squared terms.
Correct answer is
C.
C, -6. Squared times 3 gives you 6, and it's a negative. Alright,
Major motion picture.
good?
What's it?
Alright,
Yeah, that's right.
this one got a little bit harder.
Yeah, that was.
That was a nice one.
Give us integers.
Thank you.
You're welcome.
Wait.
Now he's good with fractions.
It's not gonna be the
those integers.
That was a pretty easy quadratic.
I didn't get those integers.
Tell your neighbor, tell him how you got there.
4.
Well, yeah, that's
Yeah,
the same thing.
you say first derivative, quadratic, t squared minus 16 plus 8. Then you quadratic equation.
Bro, I just looked at it.
You can't just.
You can just look at it.
I guess you can.
You can't.
I just don't
How does
remember.
one do the quadratic formula?
This is
Why'd
what.
you do the quadratic formula?
What?
Factoring.
That's what I'm saying. Like,
I
don't
didn't
do
even
the
factor. I
quadratic.
tried factoring it for 5 seconds. Like I'm done. That's not. I just
Why
didn't
would
want to. That's -4, -2. There it is. I got it.
What, David, what'd you say about your, like, previous way to factor polynomials?
The X method? No, it only works if you do the math right.
Good?
I did the. Yep. No.
That's exactly what I did.
What's the quadratic formula?
Why would you
B
do
plus or
the-
minus a third, b squared minus 4ac.
Very good.
2a.
Take the derivative, set it equal to 0.
Oh, I forgot to divide by 2.
We got 60.
No, I got 5 and 1 instead of 4. 0.
Tell your
I
neighbor.
maybe run at a more constant speed.
You just set it equal to 0.
Yes.
You guys are gonna love to solve function on your calculators.
Correct answer is
B.
3 seconds. Okay, I left this up here just for your
Thank you.
help. 2t minus 6 equals 0 for acceleration. Good? Have a conversation.
Cubic function. It's when the acceleration is equal to 0.
When the derivative of the velocity equation of an object is equal to 0.
So it's acceleration.
Oh, okay, the derivative of velocity. My bad. Yeah, no, that's relative acceleration. Whoopsies.
It's okay. It's okay. It's been a year since you did it.
What?
Reading? No, that was a reading comprehension.
I was just like, bro.
I just can't read.
It's not.
It's definitely not.
Yep.
When the derivative velocity.
It's like a certain local maximum. What if they run a line that's like y equals to
Okay. Typically, the answer would be C. But
Oh, no.
if you have an inflection point, this, you're still getting faster. But typically what you do is you're like that. And so that would be a maximum speed or a minimum, a local minimum, local maximum, typically. Not in always. But in this class, it's usually,
The correct answer is E.
correct answer, the literal answer, correct answer is E.
You can't.
Okay? Good with that?
No, it's when the derivative of the velocity. Yes. Oh my gosh.
Extreme value.
When you guess.
I don't remember how to approach this.
Have a conversation, tell them how you got there.
Well, it's gonna be the fastest or the slowest, so the acceleration. Relative zero.
Oh, yeah.
Extreme value theorem.
Oh, yeah.
And so if we're defining this as all real numbers.
The thing I remembered about extreme value theorem was, well, it's either at the start or the end, but we only have the starting point. So I just plugged 0 in. It's like, well, 0 is probably not the biggest.
So who got A?
No, I don't know what I got. I didn't get anything. I just told you I didn't know what I approached.
I hope I'm right, because I'm a little too confident about this.
Correct answer is
D.
D. Dangerous dinosaur.
Dangerous dinosaurs don't drive Durantos?
Yep.
Just 11 points in a row. I don't know.
Alright, so you're gonna do first derivative test? Yeah? Okay.
What's the first?
So you got negative 6t squared plus 24 equals 0. 24 divided by 6 is 4. Square root of 4 is 2 plus or minus, but we don't deal with negative times in this class. I would be going back in time. That does not happen in physics.
Yet.
Or it already has, you don't know. Freezing. Okay? Good? Follow-up question. Tell your neighbor what you think, how you got there.
Yes.
Ooh.
Plug in 1 for B. That's
Just
positive.
plug in one.
Plug in 1 for B is 1. Is positive.
But it's
Acceleration.
not one.
It's positive though.
It is
Plug
positive.
in 1 for B. It's also positive. It's like that one.
If it's positive, return one. It's negative, return negative one.
Oh, yeah.
That was
like,
It's
bro.
0 return 0.
Yeah.
Correct answer is?
Hey.
Correct answer is A. Velocity, ugh, at 1 second is equal to a positive 22. Okay, acceleration at 1 second is equal to a positive 18. The fact that both are positive is what we're gonna base this off of. They're both in the same direction, so you're speeding up. Acceleration is in the same direction as velocity and you're speeding up. Good? Same scenario, different question.
How's the marble moving? Well, if you ask me how the marble's moving, I tell you gravity. Oh, 3 cubed is 27. Yeah, you're right.
I don't have a
Got it, bro.
calculator. Got it.
Keep going.
Negative 27 times 2 is not going to be bigger than 24 times 3, so this is still going to be positive. The acceleration of 3 is going to be an astounding negative. I'm not doing numbers, I'm just thinking.
Tell you. Tell your neighbor.
Yes.
Correct answer is? B. B. Right with that, you get a positive velocity. You stick in 3, but you get a negative acceleration. So you are slowing down.
Positive.
Good?
Yep. Snap, crackle, pop, fizz.
Correct answer is? E.
It's June.
Good with that?
Physics is not real.
The pop is fizzle. But if you give a number, it's not exactly.
Honestly,
Derivative
it's
of
not
fizzle
that
is
way.
sizzle.
Hey man, do you know how to integrate arctangent?
Yes.
Alright.
No, you don't integrate the tangent. You integrate the other thing, it gets what?
This is really great. Okay. The miles cancel. The miles of the per cancel.
Why is that not on there? Oh, no.
I'm telling you, the miles canceled.
Silence.
Have a conversation.
Okay, so the rate of change of your miles per gallon and your miles per hour.
Yeah, miles per gallon per hour. That's gonna be.
That, oh,
divided by
my
the-
Okay, notice what I'm taking with respects to. Is that a correct verbiage?
Yeah.
With that?
Maybe.
Close
Close
enough.
enough.
That's more technical.
Like hour.
Like as a function of
Hour. Oh, wait.
The change.
weight. How would you say it in math class? As a function of,
I got it. It is B.
Function of
As a
fuel
function.
efficiency with respect. No, not that.
with respect to using that like integral.
Yeah.
It's
Hold on.
related to,
Yeah,
Yeah, because like you take like the function with respect to x, right?
Yeah.
That, so if you
With
feel
respect to
efficiency with
hours.
respect to velocity.
Okay, correct answer is.
B.
So you have,
They could do
look,
in terms.
kids, don't make this complicated. You have miles per gallon from here. This is on the y-axis. And then on the x-axis, you have velocity miles per hour. You see how, that's all you need to do. Don't make this crazy. Like, use your units to help understand. Like, once you understand the units, that's a huge tool, a lot of leverage there, okay?
Someone said.
Yeah.
No. How about no?
You both got a face fork at some point.
No vectors.
Everything rotates.